I'm sorry. All right. Yesterday, we talked about, what did we do yesterday in the lab?
We were talking about different stations. About how
We looked at light energy, right?
Yes.
And what is the very first thing we learned about, or no, not the first thing. When I was doing the laser light in the lab, what was I trying to show you?
How it reflects.
How it reflects?
By using a mirror.
What were you saying, Bria?
Try to show how light bends, reflects to another.
Okay, that was one of the things I was showing you, how I could bend the light. But before I put up that mirror, what was I trying to show you? What did I show you?
How light can travel.
And how does light travel? What did that laser do?
It reflected.
It what? It went straight. It went from this point to this point in one straight line, correct?
Yes.
And then when I put the mirror up, it went from the mirror to the other wall. How was it? I bent it, but then it went from the mirror to the wall.
And then it
What kind of line was it there?
straight.
Another straight line. So the laser showed you how light travels, correct? And how does light travel?
Light travels by
Straight. Travels in a straight line, right? Okay? So it does not curve. Okay? So light travels in straight lines. And what does this symbol right here mean?
Straight.
And where did you learn that
In math.
at? Okay? That is a straight line. Okay? Travels in a straight line.
Travels in straight line.
Do we have to draw the diagram?
Yes. Yes. Please draw these pictures as we go. Okay. So y'all kept saying this word when I put that mirror up there. What word was that?
Cool.
Reflect, right? And when I was reflecting that light off of that mirror, what was I doing to the light? I was bending it, right? And it was doing what when I bent it?
Going to the other mirror.
It was like reflecting from the other mirror.
It was reflecting, so I was bending it while it...
Well, it reflected.
What's a word I could use for that? Besides reflection. It bounced, right? So when I had that mirror up there, that light hit that mirror, bent, and bounced off to reflect on the other wall, right?
Yes.
Does everybody remember that part? Okay. So, one of two things that light does. The first thing it does is it reflects. It reflects. Or bounces off of surfaces.
Yes.
Yes, Kenneth, please draw the pictures. It reflects or bounces. So if you notice, this little girl right here is looking in the mirror, right? Okay? So the light is bouncing on them, hitting the mirror and bouncing off, and she can see herself, right?
Is it okay to take right past the line?
Now, is a mirror the only thing that light bounces off of?
No.
What else does it bounce off of?
Oh.
A window, so you can see your reflection in a window, right? Where else?
Glass.
Glass. You can see your reflection on a piece of glass too, right? If light is shining on this whiteboard, you can see yourself in the whiteboard. You can see a shadow, definitely, right? Okay. What about in a puddle of water?
Yes.
A lamp.
Yes.
Okay. So, it's not just a mirror that our light reflects off of, is it? No, it's not. Yes, even water it'll bounce off
What
of.
about silver
Okay?
lining of a car?
The paint on a car? Yeah, you can reflect off of the paint of the car too. So, one of two things it does. The first thing it does, it reflects. The other thing it does is called refracting. So, you remember when we were looking through the beakers?
Yes.
Okay? What happened in the beakers? What happened in the beakers? It made the objects bigger. Okay? So what happens when light refracts? Okay? It bends. Does that make sense? Okay? So, refracts or bends when passing through mediums. And what's a medium again? How can I explain a medium? Different materials. Okay? Different materials. You can't see that from right there. Refracts or bends when passing through mediums. Thank you. Thank you. Hmm?
Why? So much harder. Did I say Hahn? He's Hahn.
English letter.
He's Hahn.
Mhm.
Does that say when or while?
Where? When passing through mediums. Alright. Now, one of the things I want you to notice on this beaker that I drew is this light is on the outside, right? This light is on the outside of the beaker, right? What do you notice about those two lines? They're straight and even, right? Does that make sense?
Yes.
So what about this beam of light? It's not in line with it, is it? Okay? Because that's the light going through the water, so it has
Turns.
it is bent, right? Okay? So as soon as it comes out the other side, it's going to go what?
Straight.
It's going to go straight again, right? So it's going to go back to normal and in that line. Do you see that?
Yes.
Okay? Now, what color is this light right here in this room?
White.
White. Right? What if I told you that every color is in that light? Would you believe me?
Yes. Not everything. Yes. Because white is like white. White is
Yes, I would.
White is all the colors. That's brownish.
Okay. Would you grab the lights? Grab the lights.
Whoa.
Told you.
Look at the ceiling.
Whoa. Oh, I see rainbows. Wow. Oh, that's really cool. Awesome.
What are you using to make that?
A prism.
Oh, without a rainbow bow.
That's gone.
I don't know if you can see it.
All in one second.
No.
Oh, you're the believer. Oh, Miss Wilson.
Okay?
That's really cool.
That's not funny.
So, I have got this prism, right? And when I shine the light through it, it hits the wall of this prism and bends, right? and goes out the other side of this prism, and we get our
All the colors.
our rainbow.
That's really cool.
Okay? So, what color is that light?
Rainbow. All colors, actually.
Okay. White light is actually all colors
Red, yellow,
put together. Okay? Now, we have a acronym. Yes, just the one closest to the computers. Thank you. Now, there's an acronym for that. So, visible light is made of all the colors. Okay? Visible light or white light is made of all the colors. Visible light or white light is made of all the colors. Now,
It's not invisible.
so what color is Anthony's shirt?
Blue.
Blue, right? But this is white light, right? Got all the colors in it, right? So why do I see blue?
Because he has white.
How do I know that? Because all the light is shining on it.
Because all the colors make that color.
Really? All the colors make that? What do all the colors when I mix them together make?
Black.
Black, right? Does that make sense?
Yes.
Okay. Now, if all of the colors of the rainbow, red, orange, yellow, green, blue, indigo, violet, are all shining on this blue shirt, why do I see blue?
And turquoise.
Well, it's supposed to be black.
Huh? They are all shining on them. They're all shining on you, and I see pink.
Because that's the type of fabric in it.
Is it?
Or is that the color of the shirt?
But how do I see blue? Because all the color of the rainbow is shining out of that light, right? Yes, ma'am. What about the light? Because all the colors are coming out of this light.
The colors that make blue probably like are shining like
Just those colors?
all the colors. Just so bright.
What colors are coming out of this light?
All the colors.
All of them, right? All of the colors.
Oh, I know.
So if all of the colors are coming out of this light, why don't we see black all the time? No, that's still white light though, shining in this room,
Miss Hahn.
right?
It's because the blue, since they're all colors, you'll see blue because there's blue involved in a rainbow, which means you'll see blue even though it's
But how? They're all shining. Why wouldn't I see black? They're all not what? All the colors are touching, except one.
Blue.
And what's blue doing?
Blue is the color of the
Reflecting. All right. The reason that we see a blue shirt is because all 7 of those colors are beaming down, being all around this room, right? Right?
Yeah.
They're shining everywhere, right? Okay. They're even shining on Anthony's shirt, right? Does everybody agree?
Yeah.
Okay. Now, the thing is, blue is reflecting off of his shirt. So that's the color we see. Does that make sense? Okay. What do you mean?
It's reflecting off of my shirt.
That's what we see.
No, but like.
The blue is what we're seeing in the white light.
I know, but where would it like where would your
Okay? Now, yes, ma'am.
That's what I'm trying.
Where did what go? The blue?
The reflection.
It mixed back in with the light that's in the room.
But how does it?
Where did the other colors go, though?
Can we just do it again?
Yeah. Where do the other colors go?
Yeah.
So, where's the light going? The other colors of the rainbow going?
Reflecting off of our shirt.
But it's only him standing in the room. Where's the rest of that light going?
Upside.
When you're getting ready in the morning, where's the rest of that light going?
They're gonna go back to the normal.
To the light source? To the black?
It only travels in straight lines. So if it's not reflecting off of his shirt, they only travel in straight lines.
It'll be on the ground.
It's got to go through his body. How, if it bounced off, I would see that color, though. So if the light is shining, and then it gets hit something, and that's not the color I see, what's that light doing? It's not bending because it's going through his shirt. It's still there. It's staying there. Okay? So that light stays there. How many of y'all have been told, don't wear a black shirt in 100-degree weather? Why is that?
Because the sun.
Really? It's the sun?
Because the weather's gonna be really hot.
The sun has all the colors, so
The sun is white light.
It's a white light.
So that means all the color is what?
black. Well, it makes black.
It makes black. So where's all the color?
On the black shirt.
On my shirt. What does light produce when it's on for a really long time?
Heat.
Heat. So if I have all this light shining on me and it's not going anywhere because I'm wearing black, what happens to me? I get hot. So am I getting hot from the sun or am I getting hot from the light?
From the light.
I'm getting hot from the light. Okay? What about a white shirt?
Still getting hot.
Not gonna get that.
Well, not gonna get
It's a little cooler than another shirt, but what's happening to the light on the shirt?
It's still shining. All of the colors are shining on your shirt.
Okay, they are shining, but what are they doing? Because the shirt's white.
It's reflecting.
They're bouncing back off. Because there's no color. Right? Because what colors are light? White. So if I have a white shirt on, are any colors going to soak into it? No. That means every color is going to what? Bounce off of it. Make sense? Okay.
White shirts for the rest of my life, I will never get hot.
That's not what I said. Okay. So the reason I remember the colors is because Roy G. Biv told me. Roy. R. Red. O. Orange. Y. Yellow. Roy. G. Green. Biv. B. Blue. I. Indigo. V. Violet. Okay? Huh? Yes. So, here's my shirt, right, that we were just talking about. The red light goes into it. The yellow part goes into it. The indigo part goes into it. The green part goes into it. The purple part goes into it. The orange part goes into it. But what does the blue do?
Bounce off.
It bounces off.
Can we copy the Roy G. Biv?
Yes.
Did I write it?
Yes. Feels for fake color, it bounces off.
All color bounces off. Your pink shirt, for example, would be a mixture of red and yellow bouncing off of your shirt to make it pink.
Is that actually real?
Okay?
Roy G. Biv?
Same with you.
Is Roy
Different
G.
hue of green.
Miss Hahn.
Now, we see color because that color of the white light is being reflected and the others are being absorbed. Okay? With white, all the colors are reflecting, and with black, all colors are absorbing. Okay?
We're writing that bottom part.
Yes.
Yes, she was recording.
Do what?
How is it if you're showing it right there?
It's still going.
Yeah, right. It says still going.
Yeah, I see that.
It's because you need to press the button.
Did it freeze or something?
You know,
But it's not moving.
you gotta press that circle button.
I did.
Probably stop recording.